Okay, let's see if I can say some of this in a little bit different way to help it make a little more sense. We're going to start with the basic multiplication rule. There are some keywords to look for that will help you know if you're supposed to pull out this multiplication rule. So that's where we'll start. As far as keywords go, look for and. So maybe we're looking for the probability of finding a blue marble and then a red one. Or maybe both. If we want to roll a die 2 times and we want to roll a 6 both times, that would be an example there. All is one and in a row. For all, it might say, Hayden pulls 6 cookies out of a bag. What is the probability that all of them are chocolate chip? For in a row, it could be Honey, who's a dog, chases 12 squirrels. What is the probability she catches 6 in a row? All of those phrases lead you to the multiplication rule. So what does this look like? Well, in symbols, it says the probability of A and B is the probability of A times the probability of B given A. Now, I am not a big supporter of using variables for all of the things. I have trouble with just variables to label things sometimes. I like to use words. So if I change this to words, I might have the probability of the first thing and second thing equals the probability of the first thing times the probability of the second thing given the first thing has already happened. Sometimes writing it out in words like that just makes it stick in your brain a little bit better. So let's test it out. Carlos plays college soccer. He makes a goal 65% of the time he shoots. Carlos is going to attempt 2 goals in a row. There's one of my keywords or my key phrases to look for that should send off red flashing lights in your head that says multiplication rule. And that's not going to fit right there. Let A equal the event that Carlos is successful on his first attempt. So we're just going to say A is the first kick. B is the second attempt. Or the second kick. He tends to shoot in streaks. The probability that he makes a goal given he makes the second goal, given he makes the first goal, is 0.90%, or is 0.90. So that tells me the probability of the second, given he made the first, is 0.90. Now I know I'm using the multiplication rule. I'm going to write out the multiplication rule because I'm a huge, huge believer in you always write the formula first. So I know P of the first and second things is the probability of the first thing times the probability that the second happens given that the first thing already happened. Now, we've listed one thing we know. We know the probability that Carlos is going to make the second goal, given he already made the first one, is 0.90. The other probability they give us is a little bit hidden. He makes a goal 65% of the time he shoots. That means that out of 100 shots, he's going to make 65 of them. So this is the probability that he scores a goal. Whether it's his first one or whether it's his second one. So if he walks out and he only makes one shot a day, there's a 65% chance he's going to make a shot. So I'm going to plug in what I know. We're looking for this piece. I know that the probability that he makes the first kick is 0.65. The probability of the second kick, given he made the first kick, was 0.90. Then it becomes a Desmos problem. The little wiggle, the double wiggle, just means that we're using an approximation here. It means it's been rounded. And when you plug it into Desmos, you get a probability of approximately 0.585. Now this is the probability that he makes the first shot and the second shot. When we say the multiplication rule can be rewritten to find A given B, this is not something you are going to be tested over. This is ideally to show you where the formula comes from, but if we're being honest, nobody really cares. This form of the multiplication formula or the multiplication rule is on your formula chart. Yeah, so there's that. It will be given to you on your formula chart. along with this guy. And really the second form, the A given B form of it, shows up a lot more frequently. So now let's check out Carlos again. This is the probability that he makes the first goal. I'm gonna write down what we know as we go. So the probability of the first is 0.60. The probability of the first and the second is 0.30. What is the probability that he makes the second goal given, so we're looking at conditional probability, that he made the first? So we are looking for the probability of B given A, and this is a little bit sneaky because the formula you're given has the A first. So I'm going to rewrite it in words, and then we'll apply that version to the B given A part. So back up here. This is the probability of the first thing given the second thing. This is the probability of the first and second divided by the probability of the second. Well, how does that help down here with this probability of B given A? Well, I'm going to do the probability of the thing that came first and then the thing that came second. Well, my first thing is the B. So this is really going to be my first thing is B. B is that we make the second shot. Given the first shot, is the probability of the second and the first divided by the probability of the first. So I'm going to plug in what I know. Second and first is the same as first and second, so this is a 0.30 on the top. The probability of making the first shot was 0.60. If I divide these, I get 0.5. So that is the probability he makes the second shot, given he already made the first shot. Now, with independent events, remember independent events are two events that don't affect the outcome of the other. So if I roll a die and I flip a coin, the outcome on the die does not change what's going to happen with the coin. When we do this and we apply the multiplication rule, this is what we get. Well, what that does is gives us another form of this. And again, the why isn't really important as long as you know how to go use it. If your events are independent, then you don't have to go through all of this stuff with the given. You just multiply. That's it. So the probability of the first thing and the second thing is equal to the probability of the first thing times the probability of the second thing. So we'll go try it. We have an experiment consisting first of rolling a die. Then we toss a coin. Well, we just said that rolling a die does not affect the outcome when you toss a coin. So these are independent events. That means the probability of one and then the other is the probability of the first times the probability of the second thing. Well, what does that mean in terms of our problem? That means we want the probability of rolling an even number. So the probability of an even number. The second thing, what do we want? A heads. Okay, I'm gonna go figure these out. When I roll a die, my options, my sample space, looks like this. I have 6 possible outcomes and 3 desirable outcomes because I only want the even numbers. So the probability, and it doesn't matter if you reduce it now or later, of getting an even number is 3/6. If I go and look at the outcomes when I roll a coin, I can either get heads or tails. There are no other choices. So I have 2 items in my sample space with 1 desired outcome. That's not a 1, that's an H. So the probability of getting heads is 1/2. When I multiply those, and you can do it in Desmos if you want, I get 3 out of 12, and that is the same as 1/4. The days of the week problem, that's not going to come back and haunt you. We can skip over that. What gets people here is the addition rule. But I think we're going to set up a separate one for that.